Hey 8th graders, if you guys are watching this video, you guys are going to be completing the 2.3 Force in Motion Enrichment assignment today. Basically, we did the 2.3 Force in Motion assignment where you guys had the modeling tool where you had to model potential masses of different pods to figure out how they might respond differently to the same thrust or force. Okay, if you're watching this, it's because maybe there were some concepts that you were missing on that caused you to struggle a little bit more on that last assignment. So this is to help you out, help raise your grade a little bit and replace maybe 2.3 if we didn't do so hot on it. Okay, we're going to go right into it. Some of the things are going to be the same as you saw in 2.3 and some of them are going to be different. I'm going to try to keep this video as short and sweet as possible and cruise through this stuff, but please make sure you guys pay attention to like the warm-up, the little review that I'm going to do with you guys, because those are all meant to get you guys ready to redo this little modeling assessment, and then we will finish up by redoing the modeling tools and rehanding them in this enrichment assignment. Okay, so for you guys' warm-up, and this is a little bit more abbreviated than what you guys saw in 2.3, okay, you guys have these two pucks. Okay, A is the lighter of the two pucks, B is really heavy. Okay, both of them, though, are moving the exact same speed. Okay, just like you guys saw in the modeling tool, those little ACM pods were moving the exact same speed every time. Okay, these two are moving 8 centimeters per second to the right, both of them are. Okay, and what you're going to do is think about if we were to exert the exact same force on these two, how might these two pucks respond differently, or what different changes in motion might we see? Okay, so in your instructions, you are going to open up the sim. Your sim link is right here. It should take you guys into this sim where you guys notice, again, your two pucks, the light one, the heavy one, both moving to the right 8 centimeters per second. You're going to press run, then press play. Press prepare force to pause the sim to set up your forces. Okay, and then in the force panel for each object, you guys are going to exert the exact same force. So you're going to do 4 clicks to the left. Okay, so I'm going to go ahead and hit run. I'm going to go ahead and hit prepare force. Okay, and then for A, I'm going to do 4 clicks to the left. For B, 4 clicks to the left. Notice those pink arrows are the exact same size and in the exact same direction. So far, we have the exact same speed. We have the exact same thruster force, okay, but we don't have the exact same pucks, so we're going to see how they respond differently. I'm going to click exert force, okay, A stopped moving, B slowed down but kept moving a little bit. If we go to analyze, we can kind of rewatch that all as a big video, okay, and we can see that B slowed down just a little bit, so it was going 8 centimeters per second to the right. After the force, it was only going 7 centimeters per second to the right. The A puck, however, was going 8 centimeters per second to the right, and then it stopped, okay? So here's what you guys will do here is you guys are going to put your observation. Okay, so what did we notice in that sim? Okay, what happened to the A puck? What happened to the B puck? And then object B is more massive than object A. If you apply the same strength force of 40 newtons to both objects, which object will have a greater change in velocity? So what big change of motion will we see? Okay, think about A. Did A have a big change of motion? Think about B. Did B have very big of a change of motion? Okay, so which one's going to have the larger change of motion, object A or object B? Okay, pause, finish filling out slide 4, and then when you're ready, hit play, and we'll move on to slide 5. Okay, slide 5 is going to be a sim that is exactly what you guys need to think about with these ACM pods. Okay, so before you think about ACM pods, I want you guys to kind of imagine this scenario. Okay, imagine an empty shopping cart and a full shopping cart. I know you guys have heard me talk about the shopping carts a lot, but it's a really applicable thing because you guys pushed shopping carts before. Okay, imagine an empty shopping cart and a full shopping cart, and I'm talking full of heavy things. And both of them are sitting still at rest in front of you. If you were to push them both with the exact same amount of force, okay, which would speed up the most? So which one would you guys see the largest change in motion? So I want you just to think about that for a second. Okay, and why? Why would you see that change? Okay, so in this sim activity, you will examine what would happen to the space pods if the mass was different because it was either carrying more or less asteroid samples than normal. Okay? So here's what you're going to do. You're going to open up the sim link. Okay, you guys are just opening the general sim on this, so here's your link. It should take you guys into this slide. You guys can go ahead and delete the puck that's already there. Okay, Remember that in chapter 2, we are studying objects of different masses and how they move differently if we exert the same strength force on them. So you're going to go ahead and grab 3 pucks, okay? The 0.5 puck is going to represent the smaller mass of an ACM pod. So if an asteroid collection mission went out, they didn't collect as many asteroids as normal, and their mass overall was lighter than the normal pod, okay? The 1 kilogram puck is going to represent your normal pod that has what we're going to refer to as a medium mass. Okay, so it has just right. It's just the right amount of asteroids. And the 2 kilogram pod is going to represent a larger mass of ACM pod. So if we were to have something that went out, collected too many samples, and overall that pod had a larger mass than normal. Okay? All of these pods are going to be moving at a medium speed, so set all 3 pucks to move at 2 centimeters per second to the right. So let's go ahead and do that now. Let's grab our light pod, 0.5, our medium pod, and our heavy pod. Remember that our medium pod is going to be the normal ACM mission pod that we haven't had any issues with. It goes in at medium speed. It gets hit with a medium force. It stops, it docks, it unloads its samples. Okay, we know that didn't happen though. So our medium pod is our normal. It's not going to be normal, though, for your guys' claims today, okay? We're going to set all of their velocities to 2. So I'm going to click on each of them, set them all moving 2 to the right, okay? And then I'm going to go ahead and hit run and prepare force, okay? So what happens is with our little ACM pods is our thrusters weren't broken, okay? They fired still with a medium force. All 3 of these little examples of ACM pods are going to fire with a medium force as well in the opposite direction. The goal is to stop them, okay? So they're all moving at a medium speed, okay? They all have the same speed. They're all going to get hit with the exact same thruster force, okay? 2 clicks to the right, or a medium thruster force to the left, okay? And if it's a normal pod, it should stop. So we know that B is our normal pod, so what would we expect B to do? Stop, okay? So let's go ahead and hit their forces. A, 2 to the left, B, 2 to the left, C, 2 to the left. So each of those are gonna get hit with 20 newtons to the left. Okay, remember B is our normal pod, so we would expect B to stop. Okay, obviously in this mission, we knew that our pod doesn't actually stop. It eventually turned around and moved to the left. So we're going to take a look at that. Okay, so what we see is A turned around and moved in the opposite direction. C kept going but at a slower pace. If we go to analyze, we can kind of replay that and see what happened. Okay, on the next slide, you guys have a little data collection. Okay, object A had the smaller than normal mass, so less asteroids than normal. What change in motion did you observe when it was hit with the force of 2 clicks? So go ahead, pause this for a second, and answer this question. Did it start moving, stop moving, change direction, slow down, or sped up? Okay? When you guys are done with that, come back to this video. On slide 9, let's talk about object C. Remember that object B was our normal pod, and it should have done what it was supposed to, which was stop. Okay, it was our medium pod coming in at a medium speed, got hit with a medium force, it stopped. Okay? Object C had a larger than normal mass, collected too many asteroids. What change of motion did you observe when it was hit with the force of 2 clicks? Did it start moving, stop moving, change direction, slow down, or speed up? Okay, so take a second, answer that, and when you guys are ready, come back to the video. Okay, now answer the why. Why was the change of motion different for all 3 pucks? Give me an explanation. Again, think about that one keyword I've been telling you guys to remember for all of chapter 2, mass. So how does mass tie into that? When you guys are done answering this, we're going to go ahead and move on, and I'll re-explain your 2 claims for you. All right, so in this activity, you will model your ideas about how a more and less massive pod's motion would be affected by the same strength force. So again, we're looking at the same velocity of pod before our force. We're looking at the same size of our force during our force, but we are looking at a different change of motion after the thrusters exerted their force on the pod. And there's 2 claims that we have to describe that. Okay, if you remember, claim 1 says that this pod's, model this pod's mass so it shows that the usual thruster force, which was medium, would cause it to move in the opposite direction. So we need to focus in on mass on this one. So I'm going to go ahead, right click, and open my Claim 1 modeling tool. Okay, remember that when you guys get this back, okay, there should be nothing in the bottom here, okay? There is nothing also that you need to do on the top. Now, I gave you guys these the other day, but I want to do it again because I want you guys to understand that it doesn't matter the weight of the pod, it's going to move the same speed. That's how the pod was designed. Okay, it doesn't matter, the thrusters were not broken, so they're going to deliver the same strength force on all of these. Okay, so here is our medium speed. Nothing was wrong with the speed of the pod coming in. Okay, so there's our medium speed, and nothing was wrong with the thrusters, so they're going to put a medium force on the pod regardless of the size of the pod. Okay, but the change of motion will be different. Okay, so the first thing you guys need to do is you need to take a look at the claim and say, all right, this pod turned around and moved in the opposite direction. So the thrusters, so it came in at a medium speed, the thrusters fired with the medium force, but instead of stopping, like you guys see in this normal model, okay, that pod turned around and moved in an opposite direction. So which size pod or which mass of pod would cause that to happen? One that had less than normal asteroid samples like the small, okay, one that had the same amount as normal, which we know shouldn't be the answer because it would stop if it had a mass of medium, a medium mass, okay, or would it be the large size that had more asteroid samples than normal? So basically between this, you guys are choosing between A and C because if it were B, B would stop and we wouldn't have had any issues with this whole thing to begin with. So either a small mass, less than normal asteroids, or a large mass, more than normal asteroids. So choose one of those and you guys are going to drag that circle up into your before, your during, and your middle. So you should have 3 of the same circles there. So either an A or a C. So go ahead, take a second to do that now. In the before box, we already have our speed before our force. In our during force box, we already have shown the strength of the thruster force, which they weren't broken, so they fired with a medium force just like the other missions. Okay, so the last thing you guys have to do is show me the velocity of the movement after the force. Okay, so you guys had a different mass of pod that you guys should have put in these 3 boxes that wasn't your normal mass of pod, which was B, the medium mass. Okay, so if that other pod moved in at a medium speed and you guys had medium thrusters fire on it in the opposite direction, what change of motion would you see? And again, I'm going to say this a million more times. Think of the shopping cart. You guys have a light shopping cart, you have a heavy shopping cart. If you guys give them both the same force, okay, which one's going to see a bigger change of motion, the lighter one or the heavier one? Okay, if you guys are looking at the different strength pods, depending on what you chose, either the lighter one or the heavier one, if we give them the same medium force, okay, which one's going to see the bigger change of motion? Okay, is it going to turn around? Is it going to start? Is it going to stop, speed up, slow down, those kinds of things? Okay, which one's going to be the larger change that you see? Again, remember that in claim 1, the object turned around and moved in the opposite direction. Okay, so go ahead and choose the correct velocity to go on the after force puck. It shouldn't be stopped. Okay, once you guys do that, I want you guys to screenshot it and put that modeling tool on slide 13. Okay, go ahead, pause this video, finish that up. Again, really mindfully about what you need to do. All right, claim 2. Claim 2 has a different modeling tool. And remember, you guys are welcome to go back into the sim and think about what we did in that sim to kind of help you guys understand this concept a little bit better. Okay, new link for Claim 2 modeling tool, so click on that new link on slide 14. Remember that in Claim 2, we know that the pod didn't stop, it just slowed down. Okay, Claim 1, it turned around and went in the opposite direction. Claim 2, your guys' pod just slowed down. It was moving to a medium speed to the right, it just slowed down. Okay, so think about that when you guys are doing the after. Okay, in this modeling tool, again, you guys should see that the bottom row is blank. You don't need to do anything with the top row. On this one, though, we know that it's moving with a medium speed. Whatever pod you choose, there's a medium thruster force on whatever pod you choose, but instead of turning around and moving in the opposite direction like it did in Claim 1 or stopping like it did in normal missions, this pod just slowed down. So think about which mass you would need to use, A, B, or C, small, medium, or large. Okay, which pod would cause it only to slow down when we put a medium force on it? Okay, so that's the first thing you need to do is pick A, B, or C. Small, medium, or large, which puck would you use for all three of these? Again, it should be the same puck, so if you choose A, all three of these should be A. If you choose B, all three of these should be B. If you chose C, all three of them should be C. Remember that our normal pod that functions normally is a medium mass. Okay, so think about that when you guys are choosing your one for the one where it just slows down. Okay, once you guys have your puck in all three of these, you guys already have your velocity for the before. You guys have your thruster force for the during force. So all you need to do now to your puck in the after force is add its velocity after. Remember again that claim 2 is that the goal is to model this pod's mass so it shows that the usual force would only slow the pod down, not stop it. Okay, so which one shows the pod slowing down but not stopping? Okay, so drag the correct velocity up into your after force. Once you guys have the correct velocity, go ahead and screenshot that, put it in on slide 15. Okay, and you guys are done with this little part of your assignment. Again, if at any point you guys are unsure about either of your models, go back and revisit your sim instructions right here and see what happens with those three pucks that are small, medium, and large size. Okay, go ahead, double check over your work, do your wrap up. Hopefully you guys did better. Hand this in, and I hope you guys are having a great day. Bye.